Hello, hi everyone. Welcome to the Store in the Brand. Today we are going to discuss about electric current, CBSE Grade-10 physics. In the previous class, we discussed about electric circuit, electric current, potential difference, electrical potential. Okay, so we discussed all those points. Now we'll discuss about Ohm's law. Ohm's law. Okay. Ohm's law. We are going to discuss about Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. Okay. Now you can see this is a resistor. So switch and ammeter and cells, 4 cells, 1, 2, 3, 4. So I am taking 4 cells. So here across here potential difference be connected. This is the potential difference. Current is flowing. Okay. Now so potential difference across the ends of the given metallic conductor. Potential difference across the ends of the given metallic conductor is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. Ohm's law gives the definition of resistance R equal to V by I. R equal to V by I. So what are the materials required? What are the materials required? We will discuss materials required. Materials. Okay, so materials required. First one 4 cells. See here 1.5 volts each, 1.5 volts each. So each cell I am taking. Each cell is 1.5 volts each. 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. So need 4 cells, 1.5 volts of each. Second one is a nichrome wire is an alloy of nichrome wire. Nichrome wire is an alloy of nichrome wire is 0.5 meter length. And coming to third one, ammeter. Fourth one is voltmeter. Voltmeter. Fifth one is ammeter, voltmeter. 6 switch I am taking. And coming to 6, connecting wires. Okay, so these are the materials required. I hope it is very clear. Okay, so once again check those. You can check it once. So Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. IR equal to V by I. Ohm's law gives the definition of resistance. So 4 cells 1.5 volts of each. Nichrome wire is 0.5 meter length. Ammeter, voltmeter, switch connecting wires. Okay. Next one. Procedure. Procedure is first you have to connect one cell. First you have to connect one cell and note down the reading of ammeter and voltmeter. One cell and connect the reading of so note down the reading of ammeter and voltmeter. Connect two cells. Next one two cells. And note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. Repeat the process for 3 and 4. Once again, first you have to connect one cell. You have to connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. If you repeat the process, then serial number of cells. So ammeter reading, voltmeter reading by I form, that is equal to R. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Now draw the graph for VI. So if you draw the graph, VI graph, V on y-axis, I on x-axis. So that is linear for ohmic conductors. The graph is linear for ohmic conductors. VI is linear for ohmic conductors. Okay. For non-ohmic conductor, it is for non-ohmic conductors. So V on y-axis, X on I on x-axis. The graph is curved for non-ohmic conductors. For ohmic conductor, the graph is linear. For non-ohmic conductor, the graph is curved. Okay, so ohmic conductors, non-ohmic conductors, non-ohmic conductors. I hope it is very clear. So ohmic conductor means the substances which follow Ohm's law. The conductor which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductor. The conductor which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So this is about Ohm's law. Once again, the potential difference across the ends of the given metallic conductor is directly proportional to I. So at constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to I. V equal to IR, R equal to V by I. Materials 4 cells, 1.5 volts of each. Nichrome wire. So this nichrome wire is an alloy of nickel, chromium, manganese and iron metal, 0.5 meter length. Ammeter, voltmeter, switch and connecting wires. Procedure. First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay, so you can observe here. If you draw the graph for VI, okay, so For ohmic conductor, the graph is linear. For non-ohmic conductor, the graph is curved. I hope it is very clear to you all. Yes or no? So check once. Next, resistance and resistivity will discuss. Resistance and resistivity. Resistance and resistivity will discuss. So, R is directly proportional to length of the conductor. R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So, rho is the resistivity. Here I am taking R is the resistance, and rho is the resistivity. Rho is resistivity. Okay, R is the resistance, rho is the resistivity. So, resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by R equal to rho into L by A. R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. Okay. So SI unit is very important. SI unit of resistivity. So rho equal to RA by L. So SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is. So resistivity is equal to ohm meter. So very very important. Very very important. So remember this point. Once again. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R equal to R is directly proportional to L by R equal to rho into L by R is the resistance, rho is the resistivity. So rho equal to RA by L. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Resistivity is ohm meter. I hope it is very clear. So next one. So we'll discuss about resistance. Difference between resistance and resistivity. Now we'll discuss about resistance and resistivity. It's here. First point, R equal to rho into L by A. First here rho equal to RA by L. Second point is SI unit of resistance is ohm. Here SI unit of resistivity is ohm meter. And coming to the third one, resistance symbol is ohm. Resistivity symbol is ohm meter. And coming to the fourth one, so resistance depends on length of the conductor and area of the cross section. A and A depends factor. Depends on. So fourth one here I am taking. So it does not depend on length and area. Okay, so resistivity does not depend on length and area, but resistance depends on length and area. And coming to the resistance depends on temperature of the depends on temperature, and your resistivity also depends on temperature. So you can check once. These points are very, very important. Resistance depends on material of the conductor. Material of the conductor, and resistivity also depends on material. Okay. So this difference expected for 3 marks in board exam. So 3 marks in board exam. Okay. So many points are there. Resistivity, SI unit symbol. So factors and depending factors. And here also these points, temperature, material. Each and every point is very, very important. Check once. Whatever I'm explaining, you can check with your books. You can verify. So if you have any doubts, you can ask me. If any mistakes are there, let me know. Okay, so these concepts are very important. What are the concepts, whatever topics I'm explaining, those are very, very important. Okay, so highly important. Each and every point, you can check it in the previous papers also, in the previous board exam papers. So related to this one, even you can check in our pre-midterm, midterm, slip test, unit test, class test, definitely these type of questions. Okay, so related to this point, surely they will ask questions because that much important it is, right? So now we are going to discuss about resistors are connected in series, resistors are connected in parallel. Okay, next one. Resistors are connected in series, resistors are connected in parallel. Now resistors are connected in series, resistors are connected in parallel, we'll discuss. Okay, resistors are connected in series. Resistors are connected in series. Resistors are connected in series. Next, resistors are connected in parallel, we discuss. So series combination is nothing but All resistors are connected in such a way that, okay, so here I am taking 1, 2, 3. So here ammeter, R1, R2, R3, V1, V2, V3. Now entire the circuit current is same. Entire the circuit current is same. Okay. So that is nothing but Is equal to I1, I2, I3 and I. So why I am taking this one like this? Because throughout the circuit, R through R1, R2, R3 current is, whatever the current is flowing from the battery, the same current will pass through R1, R2, R3. But potential difference is different, resistance is different. Now you can see. So V from Ohm's law, we know Ohm's law, V equal to IR. V equal to IR. Okay. So Vs equal to V1 plus V2 plus V3. Okay, so by this we can write IRS equal to IR1 plus IR2 plus IR3. Sorry, IR2, right? IR2 plus IR3. Now I am taking I common. So if I take I common, R1 plus R2 plus R3. So I get cancelled. Here I am cancelling I. So the remaining values are Rs equal to R1 plus R2 plus R3. Okay, Rs equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, then the formula is Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. So very very important formula. So make sure that you are remembering this point. So throughout the circuit current is same. Is equal to I1 equal to I2 equal to I3 equal to I. Potential difference equal to V1 plus V2 plus V3. So that IRS equal to IR1 plus IR2 plus IR3. I we are taking common because current is same throughout the circuit. So I get cancelled. Rs equal to R1 plus R2 plus R3. So if n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. Okay, that is about resistors are connected in series combination. Next one, we will discuss about resistors are connected in parallel combination. Okay, resistors are connected in parallel combination. We'll discuss now. Resistors are connected in parallel combination. Resistors are connected in now parallel combination. So here you can take potential current. I am considering here current. So that is we have to connect ammeter here. Current is flowing. Battery switch. Okay. Across R1, R1, R2, R3. So here potential difference is same. V potential difference. Okay. Potential difference. So current is flowing across R1, R2, R3. So current is flowing I1, I2 and I3. So through R1, I1, through R2, I2, through R3, I3. Okay, current is dividing. So from current is flowing from positive terminal to negative terminal. So current is moving like this. The potential difference in parallel combination, potential difference is same. That is Vp equal to V1 equal to V2 equal to V3 equal to V. Yes or no? Potential difference is same. Potential difference is same. Right? Now we can take from Ohm's law V equal to IR. From Ohm's law V equal to IR. I equal to V by R. I equal to V by R. From Ohm's law V equal to IR. I equal to V by R. V by R. Yes or no? V by R. Now, so we can take Vp equal to V1 plus V2 plus V3. Vp equal to V1 plus V2 plus V3. So now, V by Rp equal to V by R1 plus V by R2 plus V by R3. So I'm taking V common. So if I take V common, then 1 by Rp equal to V I'm taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V will get cancelled. Shall I cancel V? Okay, so I'm cancelling V. Then the remaining values are 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So this is the formula for resistors are connected in parallel combination. Resistors are connected in parallel combination. Once again, so R1, R2, R3, 3 are connected in parallel combination. Current is flowing. Current is dividing into 3 parts across R1, I1, across R2, I2, across R3, I3. Right? So current is flowing like this. Potential difference is same. Vp equal to V1 equal to V2 equal to V3 equal to V. So that's why V by Rp equal to V by R1 plus V by R2 plus V by R3. Okay. So I'm taking V common. V will get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. Right? If n number of resistors are connected in parallel combination, so that is 1 by Rp equal to n by R. That is Rp equal to R by n. Okay. So is it clear? Is it clear? Just check once. Resistors are connected in parallel combination. Okay. Sorry for the inconvenience. Just a small break. So we'll continue again. Okay, just 10 minutes break. So 11:51 will start the explanation at the rate of 11:51 p.m. Means 12 a.m. will come. So we'll go to the 11:51 p.m. Still we didn't go for 12 a.m. Okay, so small break. Sorry for the inconvenience. We'll discuss after the 10 minutes. 11:51 will start. Right? Yes. Hi everyone, welcome back to the class. Okay, so now I hope it is very clear. So we discuss these points. Now we'll discuss about heating effect of electric current. Heating effect of electric current we'll discuss. Okay, now heating effect of electric current we'll discuss. Heating effect of electric current. So V equal to W by Q. V equal to W by Q. So we know W by Q. W equal to V into Q. So potential difference is nothing but work done to bring unit positive charge from one point to another point. So V equal to W by Q, W equal to VQ, and power equal to rate of doing work, that is VQ by T. We know rate of flow of charge is called electric current. So Q by T is I, rate of doing work is called rate of flow of charge. Rate of flow of charge is called electric current. I equal to Q by T. So now P equal to V into Q by T is I. So VI, P equal to VI, right? Now, so energy is given to the conductor. So that is P into T. P equal to VI into T. Whatever energy is given to the conductor, that will become in the form of heat. H is the heat produced in the conductor. So V equal to IR, we know V equal to IR. V equal to IR into I into T, then H equal to I square RT. Heat produced in the conductor is equal to directly proportional to square of current, directly proportional to resistance, directly proportional to time. So very important points. All are, each and every line is a formula. Each and every line, based on each and every line they will ask questions. Okay, you can check. Okay, you can check. Very important concept. Very important concept. Each and every line is a formula. So related to W, so W, V, P, related to this one, P equal to VI, electrical power. So heat produced in the conductor is directly proportional to square of current, is directly proportional to resistance, directly proportional time. So this is also called Joule's law of heating. Joule's law of heating. So like this, all the points are very important. Okay, make sure that you are learning electric current. Okay, and short circuit, the direct contact of live wire and neutral wire takes place. The direct contact of live wire and neutral wire takes place. Heavy amount of current will be drawn from the mains. It leads to the fire occur in the building. And overloading, high voltage appliances on at a time. High voltage appliances on at a time. Then heavy amount of current will be drawn from the mains. Okay. So that is about electric circuit and overloading, short circuit, the electric circuit, short circuit, short circuit and overloading. Short circuit is nothing but direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the mains. So that is about short circuit and overloading. So these 2 points are very important. And the potential difference in India is 220 volts and the frequency is 50 hertz. Okay, so these points are very important. And the live wire is neutral wire. The live wire is positive terminal, red insulation. Neutral wire is black in color. I'll write better. I'll write. If I say again, it's okay. Live wire, positive terminal, red insulation, red color. Neutral wire. So negative terminal, black color. Earth wire, green color. So okay, so these points are very important. So potential of live wire is 220 volts. Potential of neutral wire is 0 volt. Potential of earth wire is 0 volts. The potential difference between live wire and neutral wire is 220 volts. Potential difference between live wire and earth wire is 220 volts. Potential difference between live wire and neutral wire and earth wire is 0 volts. Very important. So remember this point. Potential difference between neutral wire and earth wire is 0 volts. So one question. So we can expect question from this. Potential difference between live wire and neutral wire is 220 volts. Potential difference between neutral wire and earth wire is 0 volts. And live wire and earth wire also 220. Live and earth wire. That also very important. Okay, I hope it is very clear. So thank you so much for joining and attending, listening the class. So if you like the video, if you like my explanation, do like, share and subscribe to Student the Brand. This is your Shiva sir from Student the Brand. Thank you so much.